Hello everyone, welcome to this session. So till now, we have introduced all the fundamentals of MATLAB programming. In this session, we will have a case study, the Kepler third law. This is an opportunity for you to practice your skills of MATLAB programming. So Kepler discovered the orbit period of the planets in the solar system is proportional to the cubic of the mean orbit radius. So in this case study, we will do three things. First, we graphically show this relationship. Second, we will compute the predicted orbital orbits of Uranus and Neptune. Then we will compare the predicted orbit periods against the actual orbit period. So this already involves some sort of machine learning. That's the simple one, the linear regression. So very interesting for you. So then in this case study, you will do three things. First, you do the log-log plots in MATLAB, and then how to calculate the line of best fit in MATLAB, and third, how to import data from a CSV file in MATLAB. As you can see, all the three things are new, right? So this is an opportunity to see that for these unknown functions, can you really understand them through self-study of the MATLAB help files online, the way you know that to search by the doc command or search by Google. And also intentionally, we add some handling table. For example, how to import a table, how to get access to column of a table. So these are the new things. So this one is an opportunity for you to learn it by yourself, as this skill is very important because we can't teach you everything. And in your work, you will always meet new things, right? So, however, if you feel difficult, so don't worry. In the next week, we will talk about the MATLAB programming skills and knowledge for the AI learning. Okay, yeah, so now let's see this case study. So here is a Kepler's planetary data from the 1618. So we can see the R with a power of 3 and the T with a power of 2. So R is orbit radius, T is the orbital period, right? So we can see the R with a power of 3 and the T with a power of 2. The ratio of them is almost the same for all the planets. So this suggests a proportional relationship of the R with the power of 3 and the T with the power of 2, right? So now we will do the task one by one. First task, create a log-log plot. Let's first get the data. So this one, to get a Kepler data, we read the table. So this is a CSV file, save the table. So you can use this command to learn. As I have said, what does this mean? You can check it, use the help file. And we will talk about it in the next week. So here I have two questions for you to investigate, right? So first one, table /1, dot height equals to an empty matrix. The other, the same table, dot age equals to I give a column vector. So what will happen? We haven't taught them yet, but you can investigate yourself and try it yourself. So then we get the radi and the periods. This is the radius and the period column of the table. We use this way to get it. And in the workspace, in the live script, you can see what the size of them are. Then we will plot a log plot. So this is a log-log command. You can see the help file about what are these, what are input, and what this function is doing. Right. So then this is a marker, as we have seen last week. Then we add the X label, Y label, title, and the grid on the plot. So the log-log plot is generated here. As we can see, the markers are here, the planets are here, the x-axis is a orbital period, and the y-axis is the orbital radius, right? So we can see it here. The second task, we want to find the line of best fit. Well, there is a function we call the polyfit. The polyfit have a 3 input, x, y, and. So here, this is a hyperlink, and you can see the help file. So this one is a machine learning task. We call it a regression. right? So this will fit the x and y. We find the best fit using a polynomial. This polynomial we can be order 1, order 2, order 3. So it's maybe it's a line, quadratic, cubic, something like that, using the x, y, and data points, right? So we specify n equals to 1, so it means we want a line as a best fit, because we have seen it's nearly a line, right? So how to do that? We want to find the best fit in the line, and by this fitting, the program will provide us m and c. So m is the coefficient, and c is the intercept. So the program we can write like this. First, use a polyfit function. We do the log periods, the log ready, because we want to, the line best fit is considering the log scale, right? We do the both log to them. So this one indicate we want a line. So this will generate the p. So p have 2 elements. The first element is the slope. The second element is the intercept. This is p1, this is p2, right? So you can see here. But we can add this line to the plot. So what we do is that we first give the x, this is the mean period, the max period. Then I will do using the m, dot multiply this plus c. So this the line is generated. This is the x, this is the y. We plot that. And note that now we are using plot, not log. So we need to make this go to exponential again. So we can plot that. So we can see the line generated is here. So it's here, right? So then the second task finished. At last, we will predict the Uranus and Neptune, the orbit radius, right? So from the line. So this is the predicted value. So how can we get this predicted value? Use P1 and P2, the M and C we have generated, right? So how to do that? The program, we can be like this. So we first provide the periods of Uranus and Neptune. Then we use this formula to calculate, and already know, multiply this plus C, right? This is P1, this is P2. Then we get the line, then we put it in the exponential to plot it. So we can see we will get these two values. We can see this is very good fit, and eventually we can plot all of them. You can see these are the 2 new points, and it's quite fit for this line, right? Okay, so that's all for this case study. So after the session, so please look at the line script and make sure you understand each line, and remember always check the workspace to see what is generated, right? And can you explain what is generated? Okay, thank you very much. Okay, bye-bye.